Hi everyone, this is Bobby at Copel TV Repair, and this is yet another functionality proof, this time for BN44-00447A Samsung power supply board that was repaired here and returned to the customer. Shortly after it was returned, the customer got back to us saying the following. I received my repaired power board for Samsung Plasma TV and installed it. I powered on the set but did not get a picture. At the same time, I detected the smell of something burning or melting. I immediately unplugged the TV. What happened? Etc., etc. And there was a bunch of other messages here that go about what happened, and I appreciate your return policy and eagerness to solve my requested feedback from the technician, etc., etc. To which we said that the problem could be in that board. Could be, it's not likely, but it could be. But it could be something else. And a good technician, I am nearly 100% certain that we do have a video on YouTube on how to test that board. Even if we don't have one how to test that board, which is going to be this one, but I think that we do. But even if we don't, we have tons of other videos that show how to test Samsung Plasma TV boards and power boards. And they follow mostly the same procedure and mostly the same logic. And here's what I'm going to really quickly tell you about it. So when power is connected to almost, again, there are some small differences, but the major structure and order of working of a plasma TV power supply board is this. When power is connected, it usually drives in a smaller or sometimes larger, but 100% always smaller compared to some other transformers and transformer circuits that provide standby voltage. That standby voltage is usually 5 volts. Sometimes can be 3.3, sometimes can be a little larger, higher, but for Samsung boards I cannot remember one. Usually it is 5. And it's usually driven by a smaller transformer. In this case there is a relatively bigger one, and that means that it also provides some other voltages that in the beginning do not matter. But some portion of that transformer takes the input 110 volts. There is an IC somewhere that drives that transformer. In this case, this would be here. And it just provides an output voltage that is called standby voltage. It would be on one of the connectors. And in this case, this will be the upper connector. This will be the A5 volt voltage. On that same connector, there will be another pin that is called PS on, or some variant of that, PS on, power on, P on, something like that. And that pin is usually activated by grounding. And by default, there will be voltage on it if there is nothing connected to that connector. And to activate the power board, to tell it to wake up, the vast majority of the board doesn't work. Only this small transformer produces something, possibly a few other things, but they're not let out. There's something that's stopping other voltages usually from going out until this standby voltage returns back to the board in the form of the signal PS on, power supply on, that basically tells it is sent by the main board when you press a button or when the main board detects infrared control. It basically uses the standby voltage, extremely low power, low voltage. All it does, the main board, is sensing whether you press a button or whether you hit the remote, and then it starts waking up, and one of the very first things it does is waking up, is telling the power supply board to wake up by grounding, and that means sending that pin, and this is pin number 1, which is the bottom pin here on this connector. On other boards it will be different, but what it does is it sends that pin to ground. What this does on that board, it travels all the way back, and it does several things. Number 1, it activates a circuit known as a power factor correction circuit. All plasma TV power boards have it, and most of the LEDs, though not necessarily all of them. And this is something that has been mandated in order to preserve efficient use of electricity when various loads, etc., etc. Let's say there is a circuit that needs to be in those supplies, and it is in those supplies. It's called power factor correction, and what it does is it takes the input voltage from 110 and it raises it up. Well, not that voltage itself, that voltage stays at 110, but the rectified voltage, instead of 160, it raises it up to 390 to 400 volts. And you can usually detect the presence of that board by such large coils and a pair of powerful transistors, and somewhere there is a powerful diode. It's probably under those heat sinks. I don't see it, but I know it is there. Large coils, left side of the board close to the power, PFC. And what happens is the output voltage on those capacitors, and those are the main capacitors that drive the really heavy power that's necessary for the display, for the plasma display panel. The voltage on those capacitors should rise when the board is activated through here from 160 to 390 to 400 volts. Exact value doesn't really matter. There may be minor differences. Some boards may be 390, some maybe 395, some maybe 402. As long as it's stable, that means the PFC circuit is working fine. PFC circuit is one of the most commonly failing circuits in such boards because, well, it deals with high voltage, high power, high frequency in order to convert this 160 normally rectified voltage out of the AC, raise them up to 400, and the reason again, it doesn't really matter why it raises them, it must do it. Second thing that board does, usually it is conditional upon the release. There is a little circuit that detects whether the 400 volts come up or not, and when they do, the second relay closes here. One of them closes as soon as this is passed. The other one, once this is raised up, closes the second relay. Well, it does by closing the second relay does not really provides the power. It does something else usually, but the other thing that happens is those 400 volts start driving the circuitry that utilizes large transformers, or in this case it could be that transformer, and that could be incorrect. This could be the standby, this could be the secondary, or the other way around. It's the way to find out is basically just to trace which goes to here, which is the standby. It will go to one of those. Another way is to trace the rectifiers, going forward, seeing which ends up where. It doesn't really matter for our case, but the one or two large transformers here are reserved for an output voltage of the highest possible value on that board. It's called VS. And it's accompanied, in some boards they go on the same transformer, on some they go separate, on some boards they're activated at the same time, on others VA, because VA is much lower, it's about 60 volts, whereas VS is about 207, 220, anywhere there, 200 to 220. This is high voltage, high current, lots of power, lots of protection to VS, and this is the second most common failing circuit, the one that provides VS. Now, in order to activate VS, though, there is a second pin here that is called, it's going to be on another connector, this connector, it's called VS on. Now, unlike the board activation pin, which requires grounding, VS on, usually, and especially on Samsung plasma boards, is activated by sending 5 volts. You can send 3.3, you can send 5, either way will be fine. The proper way to do that will be always through a resistor, etc. But if you are somebody who does that for a living, you can sometimes skip the risks and make things simple. So what we've done here is like we've done with many other boards. When we have to test such a board, we made a connector jumper that is used for testing first the power board activation and then the activation of the VS. And what I have on the other side of here, I will talk about this in a minute. So let's start with just turning on the board. I'm going to switch that to 0 volts, and I'm gonna turn on power. This is how we have that here. It did click once, and what's gonna happen now is several things. First, I heard it click. You probably didn't, but what I'm gonna have here now is 160 volts on all those capacitors are in parallel, and I can measure 160. Oh, my bad, because it's already activated. It measured 340. So without the board activated, as it comes, the very first thing that you want to measure is actually the standby voltage. And you do that by checking ground, which in my case can be, let's say, this. And this to standby. Hold on a second, let me see where can we find good 5 volts. First, where we can find good ground. Yeah, that will do. Excellent. And then good 5 volts. Let's see. The manufacturers usually leave jumpers around connectors for easier testing, but in this case I will be testing straight to the pin. So the very first pin that I'm testing here, the bottom one, is the PS on. As I told you, this one will have high voltage. It needs to be grounded in order for the board to be activated. However, what I want to do is I want to test the next pin to it, and this is 5.4. Now the voltage on the PFC, on the mains filters, is any right side leg and any left side leg will give you the voltage that we care for. Now it's dropping down because the board was just activated a minute ago, and it's going to take a while for all this to go down, but it will stop at 160 volts. And what I'm going to do now is I'm going to plug this, which basically inside the connection simply has the lowest pin, PS on, shorted with one of the pins that is ground. And when I do that, it will click. I don't know if you will hear that. Not yet. Trying to. Oh, it did click. I don't know if you heard it, but the very first thing that will happen, if it doesn't explode whenever they are faulty, is the voltage on the mains capacitors. Again, any left to any right, make sure you don't short them, is 396 volts. Good news, PFC works. There is still no VS, VA output voltages, and the way we do that, let me check if there is a VA, because sometimes VA is separately activated from VS, but no, there is nothing on the VA, and neither is there on the VS. Those are the testing points. But when I plug in this connector here, that basically sends 5 volts to the rightmost pin, which is called PS on. Nothing is heard or seen on the board. The switch is not mechanical like the first activation, it's electronic. But now when I touch VS here and the other probe is ground, what I do have is 217 volts. More importantly, I have actually loaded the board with something that is an artificial load. Many guides will tell you to use the old style lamps for that. There are a number of reasons, starting with the fact that you can no longer easily find those. Of course, you can use electronic load or other stuff, and what we use is just two very powerful